You're welcome. Now let's look at product rule. So there's a problem here, which is a function. We'll be finding the derivative of a function using product rule. Then we know how to apply product rule in finding the derivative of a function. So now let's look at the solution of the function. So firstly, we will divide the expression into two. So before you know that the function needs product rule to find its derivative, you have to notice if there's multiplication in the expression. You have to notice, or you have to know if there's multiplication in the expression. So if you look at this expression, 2x to the power 5 is multiplying this bracket. So there's a multiplication in the expression. So therefore, we have to apply product rule to find the derivative of the function. So we therefore divide the expression into two. Then we name them as we want. So I am using u and v. So the first part of the expression, which is 2x to the power 5, is u. Then 4x squared plus x is v. So I've separated them and labeled them as I want. So now let's look at, there's a formula that we go by in using product rule to find the derivative of a function. And that formula is u multiplying the v plus v multiplying the u. Now the u is the differential of v with respect to x. So we differentiate v, which is this, with respect to x. Then the u is differential of u with respect to x. So after finding the differential of u and v, then we substitute them into this given formula so that we find the derivative of the function. So now let's look at the steps at which we use to find the derivative of these separated expressions from the function. So firstly, we look at the v. So we are differentiating 4x squared plus x. We are differentiating 4x squared plus x. And with differential, the first thing you have to do is you look at the variable. Either the variable has a coefficient or an exponent. So if it has a coefficient greater than 1, you separate it from the variable. If the variable has a coefficient greater than 1, you separate it from the variable. So as we did here, x had an exponent of 4. So we separated it from the variable. Then now we come to the exponent of the variable. So for differential, you bring the exponent of the variable in front of the variable as we've done here. So as we've done here, you bring the exponential in front of the variable. And after that, you subtract 1 from the exponential. So if x to the power n is the expression of the function, then the differential of that expression will be n x to the power n minus 1. N x to the power n minus 1. So as you can see here, we have 2x squared to the power 2 minus 1. So this is how we find the differential of a variable. So after that, we do same for x. Coefficient of x is 1. So we've written that. Then we brought the 1, which is the exponent of that. We didn't write. We brought it here as its coefficient now. Then we subtract 1 from it. Now, any number to the power 0 is 1. So 1 minus 1 gives us 0. So x to the power 0 is 1. Then you multiply 4 by 2 to get 8. Then 2 minus 1, which is 1. So therefore, the differential of v with respect to x is 8x plus 1. So therefore, the v is 8x plus 1. So now we do same for u. So u is 2x to the power 5. So we separate the coefficient from x. So 2 here. Now bring 5 in front of x. Then subtract 1 from its exponent. So we are getting 2 times 5, which is 10. Then 5 minus 1, which is 4. So the u is therefore giving us 10x to the power 4. So now we've gotten our du, we've gotten our dv, we know our u, we know our v. So therefore we take this equation to find the product rule for this function. So the derivative of f of x, which is f prime of x, equals u dv plus v du. So we will do our substitution. You take the u, which is 2x to the power 5. Then we take the v, we had it as 8x plus 1. So here's our dv. Plus our v. Our v is 4x squared plus x. So here's our v. Then our du, which is 10x to the power 4. So here's our du. So we've done all our substitutions. Now the next thing we will do is simplification. We have to simplify the expression to get its simple form. So we are supposed to simplify the expression. So multiply 2x to the power 5 by this bracket, then multiply these two to get its simplest form. So 2 times 8 is 16. Then x to the power 5 times x. So we know indices that when two base numbers are multiplying and the base numbers are the same, we add the exponent. So x to the power 5 times x. We add the exponent 5 plus 1, giving us 6. So the x with no exponent means the exponent is 1. So we add 5 to 1, then giving us 6. So 2x to the power 5 times 8x is giving us 16x to the power 6. Then 2x to the power 5 times 1 will give us that. Then after that, multiply this by that, which is 4 times 10, which is 40. Then x to the power 2 times x to the power 4, which is x to the power 6. Plus x times 10 to the power x to the power 4, which is 10x to the power 5. So we've done the multiplication, then the expansion of brackets. Now we have to group like terms to simplify it. So we have x to the power 6 here, x to the power 6 here, x to the power 5 here, then x to the power 5 here. So we group the like terms, then we add them up. So now 16 plus 40, they have the same exponential. Then 2 and 10, they have the same exponential. So we simplify them, then we are having 56x to the power 6 plus 12x to the power 5. So the derivative of f of x is 56x to the power 6 plus 12x to the power 5. So this is the approach at which you go by to use the product rule to find the derivative of a function. Now here's another question. Pause the video and here's the answer, and solve if you get this answer. So now into the solution of this problem, we will divide the expression into two as we did for the first question. So if you look at this question, we have an x squared plus 2 in one bracket, 3x cubed minus 5x in another bracket, and they are multiplying. So we can divide them into two, then apply the product rule to find the derivative of this expression. So our first bracket will be u, which is x squared plus 2. Second bracket will be v, which is 3x cubed minus 5x. So we've gotten our parts from the expression. Now we know the equation for the product rule, u dv plus v du. So we find the v, then we find the u. So du, u is x squared plus 2. So du will be equal to 2x. The coefficient of x squared is 1. So you separate that. Then we bring the exponential of x squared in front, which is 2. Then subtract 1 from 2, giving us 2x. Now the differential of a constant is 0. Whenever you find the derivative of a constant, you get 0. So therefore, the differential of 2 is 0. So du is therefore giving us 2x. Then we do the same for dv. dv is 3x cubed minus 5x. The coefficient of 3x cubed is 3, so we separate that. Then we bring the exponential of x cubed in front of it, so it's here. Then subtract 1 from the exponent, giving us 9x cubed. So we multiply the initial 3 separated by the 3 you brought from the exponent to multiply the x to get 9. Then we subtract 1 from 3 to give us 2. So here is 9x cubed after finding the derivative of 3x squared. After finding the derivative of 3x cubed, we are getting 9x squared. Then 5x, we separate the coefficient, which is 5. Then we bring the exponential, which is 1, to multiply the 5, so we are getting 5. Then we subtract 1 from the exponential, which is 0. We subtract 1 from the exponential, which is 0. So therefore, x to the power 0 is 1. So this part will give us 5. So the dv is therefore 9x cubed minus 5. So we've gotten our du, we've gotten our dv. So now we take the product rule again. Then we do our substitutions. We know our u, we know our v. We've determined the du, we've determined the dv. So let's do the substitutions to know the derivative of this function. So our u is x squared plus 2. So we've done that substitution. Then our dv is 9x squared minus 5. So we've done that substitution too. Then our v is 3x cubed minus 5x. We've substituted that. Then the u is 2x. We've done that. Now we have to expand the bracket to get this answer. So x squared multiplying 9x squared will give us 9x to the power 4. Give us 9x to the power 4. Then x squared will multiply minus 5, which give us minus 5x squared. Then 2 will multiply 9x squared. You are getting 18x squared. Then 2 multiply minus 5, you are getting minus 10. So we've expanded this bracket. Then 3x cubed multiply 2x, you are getting 6x to the power 4. Then minus 5x multiply 2x, you are getting minus 10x squared. So the approach we used earlier on, we use same here. The same base, they are multiplying, we add the exponent to get the answer. So now after the expansion of the bracket, we then have to group like terms. So we have 6x4, we have 9x4, we can group them. We have x squared, we have x squared, we can group them, then we simplify. So after grouping 9x to the power 4 plus 6x to the power 4 minus 5x squared plus 18x squared minus 10x squared minus 10. So we simplify 9x4 plus 6x4, we are getting 15x4 minus 5x squared plus 18x squared minus 10x squared, you are getting 3x squared minus 10. So this is the derivative of the function when product rule is applied on it. So now this is how we go by using product rule to find the derivative of a function.